Welcome. In this video, we are finishing up Chapter 5, Rational Numbers, with the section 5D, the decimal expansion of rational numbers. And in fact, this brings us to the end of Part 2, Making Sense of Numbers. In this video today, we'll do a few things. We'll talk about how to turn fractions into decimals, and then the other way around, how to turn decimals into fractions. We'll focus on terminating decimals and repeating decimals. Here we go. So fractions turned into decimals either terminate or repeat. So every fraction that turns into a decimal, it either terminates or repeats. Here's an example, 1/25th. As a decimal, that's 0.04. And it just stops. That's the end of it. That is a terminating decimal expansion. The fraction 47/220ths, that becomes 0.21363636 forever and ever, where the 36 keeps repeating. So that's an example of a fraction with a repeating decimal expansion. Now, I do have some digits at the beginning that don't repeat, but that's okay. As long as the decimal expansion eventually repeats, we call it a repeating decimal expansion. Now, sometimes you might see this written as 0.21, and then there's a bar over the 36. The bar over the digits means that they repeat. If you don't use the bar, then it's sort of tradition to at least write out the repeating part 3 times so that the reader has a sense of what gets repeated. Turning fractions into decimals is easy. Use your calculator. But there are some simple fractions that you should know how to do right away without a calculator. Whenever your denominator is a power of 10, you should do that in your head. You should not have to reach for a calculator to do that. Let's take a look at some examples. 27/10. All right, I think of 27, and there's the decimal point at the right. And then dividing by 10 really means move that decimal point 1 place to the left, giving me 2.7. If I had 27 divided by 100, all right, I start by thinking of 27 with a decimal point on the right, and then I move 2 places to the left, 1, 2. So I end up with 0.27, and that's my answer. What if I have 5 divided by 1,000? All right, there's 5, and I put the decimal point to the right. Now, 1,000 has 3 zeros, so I move to the left 3 places, 1, 2, 3. And there are some blank spaces, so I need to fill those in with zeros. So my answer is 0.005. That's the same as 5 thousandths. And then how about this last one? In this case, I actually have a decimal point in the numerator, which is a little bit unusual, but that's okay, it's fine. I'm dividing by 1,000, which means I'll move the decimal point 3 places to the left. I move the decimal point 1 place to the left for every 0 that I see in the denominator. So let's see, I start with 79.21. It moves 3 places to the left, which means 1, 2, 3. I fill in that space with a 0, and I get 0.07921. Here's really the big question, the one that takes a little bit more time. How do you turn a decimal into a fraction? Now, if it's a terminating decimal, that's pretty easy. If it turns out to be a repeating decimal, then that's a little bit tricky, but actually very cool. So we'll see that in a moment. But first, number 1, terminating decimals. Convert a terminating decimal into a fraction. So here's an example, 0.4. I sort of reverse the process that I saw before. Whenever I have a terminating decimal, I can write it as a fraction where there's a power of 10 in the denominator. So I actually kind of reverse the process. I think 0.4, and then I need to start moving the decimal to the right. And how many places do I need to move it until I get to the right of the number I have? In this case, I had to move it 1 decimal place, which means I'll end up with 4/10. How about this situation, 0.528? There's the answer, 528/1,000, but how did I get that? In my mind, I was thinking 0.528, and I thought, how many places does this need to move to the right? 1, 2, 3. And so 528 over, and then 1 followed by 3 zeros. Now, you can reduce. And it turns out that with a little bit of arithmetic, this fraction reduces all the way down to 66/125. But generally, as long as you can get at least that first fraction, that's the most important part. 20.08. You see I need to move 2 places to the right. So this becomes 2008 divided by 100. Since I'm moving 2 places, I divide by 1 with 2 zeros. And that reduces to 502 divided by 25. Here's one for you to try. Pause the video for a second and see if you can write this one out. Get the solution, and then when you are ready to check your work, start the video again. Okay, give it a try. All right, welcome back. I'll assume that you have given this a try. How do we do this? Well, first of all, I need to count how many places do I need to move the decimal. It looks like I need to move the decimal 1, 2, 3, 4 places to the right. 4 places to the right means a 1 followed by 4 zeros. 0, 0, 0, 0. And then in the numerator, 6, 5, 4, 3, 2. And there you have it. Let's take a look at the more challenging but more interesting problem of converting a repeating decimal into a fraction. I'll do 3 examples. Here's the first one. Example 1, convert 0.1587587587 into a fraction. We see that the repeating part is 587, and there's a 1 at the beginning, but that's okay. The first thing to note in this procedure is identify how many digits long the repeating part has. In this case, the repeating part has 3 digits. Okay, let n be that original number that I started off with. So n is just, I'm giving it a name. And I'm going to, down the road, I'll be able to find a fraction form for n. Now here is kind of the tricky part. I take that n and I multiply by 1,000. Now, why did I use 1,000? It's because 1,000 has 3 zeros, and my repeating part was 3 digits. This is important. If the repeating part only had 2 digits, I would be multiplying by 100. Or if the repeating part had only 1 digit, if it was like 0.22222222, then I would be using 10n. However many digits you have, however many repeating digits you have, you multiply by a number with that many zeros. Okay, let's continue on. So why did I do this? Well, the next step says, let's take my original n and subtract it from the 1,000n. And so you can see on the right, that's my original number, my original n, and I'm subtracting. And here is the magic that happens next. On the left, 1,000n minus n is 999n. But look what's happened on the right. When you subtract decimals, you have to make sure that the decimal points line up. And look at this. The 7 matches up with a 7, so that goes away to 0. I might as well just put a 0 there. 8 matches up with 8. That's 0. 5 minus 5 is 0. 7 minus 7 is 0. 8 minus 8 is 0. 5 minus 5 is 0. But then 7 minus 1 is 6. I put down the decimal point. 8 minus 0 is 8. And then 5, and then 1. This is the reason why we multiplied by 1,000. That number gets shifted over by the same number of places as the repeating part has. So by multiplying by 1,000, I've forced the repeating parts to line up perfectly. So when I subtract, all that repeating part drops away. That's a pretty clever trick, right? Okay, let's continue on. We're not done quite yet. Now that I know that 999n equals 158.6, now I need to solve for n. And I do that by dividing both sides by 999. And I find that n is 158.6 divided by 999. Now, it's not usual to see a decimal point in a fraction, so I need to multiply the top and the bottom by 10, which moves the decimal point 1 place to the right and puts an extra 0 on the bottom. So I end up with 1586 divided by 9,990. And look at that. That is a fraction that gives the decimal that I started off with at the very beginning. That's kind of cool. Now, the fraction I have here is not reduced. You can clearly see this because the numerator is even and the denominator is even. But actually, I don't even really care. What's important is we found an honest-to-goodness real fraction that gives this repeating decimal expansion. Let's do another example. Convert 0.292929 into a fraction. I observe that the repeating part has 2 digits. So I let n be the original number, And now I'm going to multiply n by something. Do you remember what I'm going to multiply n by? I'm going to multiply n by 100 because 100 has 2 zeros and the repeating part has 2 digits. And then I'll subtract off n, line up the decimal point, and because of this trick, all that repeating part falls away. All the 9's cancel and the 2's cancel, and I'm just left with 99n equals 29. I want n by itself, so I'll divide both sides by 99, and I end up with n equals 29 over 99. Pretty cool. Once again, and this one actually is in reduced form, so there's nothing else to do. And you can always double check your work by actually pulling out your calculator and doing 29 divided by 99 and seeing what you get. One more example. Convert 0.460877777 into a fraction. And actually, I'll invite you to pause the video, give this a try, see what you can do, and then start the video again to check your work. Okay? Give it a try. All right, I hope you have tried this, and let's check your work. The repeating part has 1 digit. It's only the number 7. So I let n be my original number, and then I'll create 10n. I use 10 because 10 has 1 0, and there's only 1 repeating digit. And then I subtract off the n just like I always have. And like before, the repeating part falls away. 0, 7 minus 7, 0, 7 minus 7, 0. But eventually I get to a point, 7 minus 8, where I need to do a little arithmetic. So I'll call that a 7, put a 1 down. 17 minus 8 is 9. 7 minus 0 is 7. 0 minus 6, okay, again, I need to call that a 5 and put a 1 in front. So I get 10 minus 6, which is 4. 5 minus 4 is 1. Put down the decimal point, put down a 4. And that is my 9n. So I have 9n equals 4.1479. So n, I'll divide both sides by 9. So I get 4.1479 divided by 9. And then let's clean it up a little bit because we don't usually see decimals in the numerator or denominator. So how much do I need to multiply by? So I need to move this decimal point 1, 2, 3, 4 places to the right. So on the bottom, I'll append 1, 2, 3, 4 zeros. And on the top, I can write 41479. And you can check your work by actually pulling out your calculator and doing the division. And that will do it for this section. We've looked at converting fractions and decimals. When you convert a fraction into a decimal, that's pretty easy. You just use your calculator. And when you convert a decimal into a fraction, well, for terminating decimals, it's not so bad. But for repeating decimals, we have this cool little trick where we can convert a repeating decimal into a fraction. All right, this is a good place to stop.